I guess most of us are aware of the fact that the computer has come to play an increasingly important role in our everyday lives.
You can say that again. In the last episode, we saw how different microcomputers each came with their own proprietary software.
I'm curious about CPM and how it could enhance a home system.
It's a way that you can get many computers to be compatible so that perhaps you can transfer programs from one to the other.
CPM was a DOS. It handled all the hardware addressing in a general way, like how drivers are used today. It also let users work with files on a disk instead of saving the RAM to an audio cassette. And it came with software and instructions for programming CPM applications. So, on all 8-bit microcomputers of the 70s, programming was a key part of the user experience.
Now, when you first bought your Commodore 64, you may have bought some programs to go with it. That's pre-written programs. But if you wanted to write your own programs, to get the machine to do what you wanted to do, you'll have to learn a programming language.
Your computer will do exactly what you program it to do, nothing more. You must tell it all it needs to know to accomplish your task. If you leave out even the smallest instruction, your computer will not run a program correctly.
Well, there are three major levels of computer programming languages that sort of depend upon your level of sophistication, what you're going to use the language for. The lowest level is what's called machine language, and that's the language the machine understands, the ones and the zeros.
I think it's rather good fun to teach them some machine language, to let them have some insight as to what's going on inside the machine at the actual bits and bytes level, rather than thinking in terms of a pseudo-intelligent entity which one tends to think of in a higher level language.
The next level up from that is what they call systems languages, and the languages like the programming language C would be in that category. And those languages are used to program applications such as word processors or spreadsheets.
You could teach the computer to understand English?
Well, no, but we can actually put a particular synthetic language, which is largely technical and which is, to some extent, algebra too. And this jargon, which is understandable to a person, is much easier to work with than numbers.
I see.
And then the third level, the highest level, is what's called an application language or an end-user language. And there's languages like Fortran, COBOL, Logo, so forth fit into that category.
Logo and its turtle made up a high-level educational programming language which sought to bridge the world of physical objects and writing code in an intuitive way.
You've come over to Logo recently. Is there any special reason why?
Well, first of all, I just think it's fun. I'm enjoying every minute of working in Logo. It doesn't seem like programming. It seems like playing or something like that. I get a kick out of it. And then I also believe it's great for children, and that's what my research is about.
David?
The interesting thing about kids is that they take to this like crazy. They glom onto it like TV. And in the 5 years or so of studies that have been done by people getting kids to cause an information manipulator like this to do things for them have been quite remarkable. They start off, Papert, for instance, starts off with a turtle. It's a device that sits on the floor and has a magic marker that can drop out of its rear end. If you say forward 10, the turtle clanks forward 10 notches. If the pen happens to be down, it leaves a track. So if you say right 90, it turns right 90. If you say forward 10, it goes forward 10 more notches. Do it a few more times and you have a square.
Children learn by experience of the world around them. That was the message of the Swiss educationist Jean Piaget.
Okay, the important thing is that the kid has done something that he wants to do, but in doing it, he has exercised one of the most important things, I think, in human thinking, and that is the exercise of strategies and looking ahead, planning, taking something that's complicated and knocking it down into simpler things, and so on.
Plastic robots, arrows on screens, hyperactive sprites all belong to the same turtle family. They all obey the same commands. By getting to know these turtles as they get to know a person, these children are learning to be mathematicians. This is Piaget's real message, learning rooted in experience.
The essential point about the turtle is its role as a transitional object, that is, a transitional between the body, the self, and abstract mathematical ideas. The turtle can be, you can identify with it, you can move your body in order to guess how to command the turtle. So it's related to you, to the body, to the human, and it's also related to mathematical ideas because its structure is such that it captures some extremely powerful geometric and physical ideas.
Of course, programming knowledge wasn't necessary to begin applying computers to solving a real-world task.
There seems to be this inherent feeling out there in the world that in order to use a computer, one must be conversant in programming. Forget it. Programming doesn't matter. There are readily available applications that one can purchase and run their business on.
The replacement of the typewriter and the process of accounting by hand were two major applications.
I'm able to do an awful lot of creation of documents in a word processing application, for example, which is probably one of the most useful applications that people have for computers. You're able to create documents, edit them, change them, revise them, do whatever you wish, and mark them up to your heart's content, either yourself or with your secretary working at the keyboard. And the beauty of it all is you can go through the whole logical sequence that one of the other people were talking about before, express your ideas, put them into a proper format where everything just follows so logically. It's a way of expressing yourself.
Dan Brickland's professor at Harvard showed how companies used a grid of numbers on a blackboard to work out profits and expenses. Students were asked to calculate how future profits would be affected by various business scenarios. It was called running the numbers, and they did it laboriously by hand.
I imagined that there was this magic blackboard that did like word processing does word wrapping. If you make a change to a word, it automatically pulls everything back. Well, why not recalculate the same way? So that if I changed my number, I should have used 10% instead of 12%. I could just put it in, and it would recalculate everything, go through it. And that would be this idea of electronic spreadsheet.
Now we've set this up, okay? Then we type a new value in, okay? Here I'm going to take that 100, and I'm going to change it, all right? And here, it recalculated. Whoa! That saved me so much time.
People who saw it and went and got it, like an accountant, I remember showing it to one around here, and he started shaking and said, "That's what I do all week. I could do it in an hour." What I could do, and they would take their credit cards and shove them in your face. I meet these people now, they come up to me and say, "I got to tell you, it's...
you changed my life.
You changed my life. You made accounting fun."
Ah, so here we are. And then press Enter. Where's Enter?
It's the large key with the arrow bent to the left.
Oh, here we are.
I'm moderately familiar with this keyboard. Of course, one gets more and more facile as you get used to it. And this is one of the problems. We have to study the human engineering, too, of people learning to use equipment.
This is a computer spreadsheet screen. This is a computer spreadsheet screen. And so is this. If they look similar, that's part of the reason for a sudden increase in lawsuits between software developers.
As a user learned to interface with an application, they could start to ignore the hardware reality of photon and bits and focus on the meaningful content of the memory.
Get a file, press G, and Scrooge. File in memory. Well, where is it?
Type E for edit and you'll see it.
Oh, there we are.
More and more, typing, accounting, and record keeping were being done through the window of a screen in a virtual world inside the user's mind, built up of metaphors afforded by the user interface of the application.
Consider the word processor, which is really just a computer, plus a word processing program. You use the computer's keyboard to send your words into the computer's memory. And you use the computer's screen as a window on these words, so that you can see what you're doing as you use the word processing program to cut and paste the words to your satisfaction.
The old medium is always the content of the new medium, as movies tend to be the content of TV, and as books used to be the content, novels used to be the content of movies. And so every time a new medium arrives, the old medium is the content, and it is highly observable, highly noticeable. But the real roughing up and massaging is done by the new medium, and it is ignored.
As a user learned to interface with an application, they could start to ignore the hardware reality of photon and bits, and focus on the meaningful content of the memory.
This means that once you have a word processing system, you really have a self-contained little office with its own built-in typewriter, filing cabinet, mailbox, and scissors and glue, all rolled into one.
Microcomputers started with hobbyists and entrepreneurs, but flourished with the ready-made software which was useful for users in the mass market. Programmers and users. Computers and applications. Long-standing theory and quick-moving markets. Two different ways of thinking about the same machines. But many more changes were in store. Coming up on Silicon and Charybdis.
In the future, all applications are going to have these pulled-down menus and a common way of interacting with the user.
The man-machine interaction is very poor. Now, this largely stems from a problem of the fact that we must put only one problem in the computer at a time, fundamentally.
We try to acquire cultural literacy, knowledge about our environment. But from the point of view, again, I'd like to say that people can function very well without computers in their lives. However, the school system is attempting to turn out people which are more rounded, and I think that that's what our task and our goal should be, to try to make these people basically literate and functional in this environment, and therefore they should know something about programming, and we should try to incorporate the concepts of programming in the curriculum, in problem-solving activity. In that sense, I think it'd be very useful.
It was easy to build. None of us are hackers. We aren't programmers, and this was something that we could do without having to learn a new language.